All right, welcome to Class Bridge. If this is the first time you are coming across this YouTube channel, you can subscribe to this channel because on this channel, we give detailed explanation on concepts that students find difficult in the class. So let's get started. Under Laurent expansion, if you are given questions like this, for example, find the Laurent series about the indicated singularity. You have to name it and give the region of convergence. How do you solve problem like this? The first thing you need to take note of is that you need to understand the concept of Taylor series, that is the Maclaurin series. Let's quickly do a revision on that. On Taylor expansion, you have something like this, the summation of this is a special case of Taylor series that is called Maclaurin series. That is at the point where A is equal to 0. So now if you have something like this, you should be able to expand some functions in this form. So for example, let's say we have a function e raised to power x. How do you expand it in this form? Differentiate the function, which is still e raised to power x, differentiate it further, which is still e raised to power x. When you differentiate it again, that is the third time, it's still e raised to power x. Then when you slot in x to be 0, the first function gives you 1 because anything raised to power 0 is 1. So now this also gives you 1 and this also gives you 1. That is at f prime of 0 is equal to 1. The same thing for this. When this is 0, this gives you 1. When this is 0, this gives you 1. Now let's slot it into the Taylor series or Taylor's expansion. Now if you are to follow the Taylor's expansion, it means e raised to power x is the same thing as when n is equal to 0, then f of x, that is when you have not differentiated it, gives you this. And when you look for the value of this when x is equal to 0, it gives you 1. So it means this here is 1 over n factorial when n is 0, that is 0 factorial times n raised to power 0 when n is 0, plus, because of the summation here, you have the next one is f2. Now when x is 1, you have f1, which is this. That is the when f is differentiated the first time is 1 when 0 is slotting over 1 factorial times x raised to power 1. The next one is still 1 over 2 factorial x raised to power 2. And when n is 3, you still have 1 over 3 factorial, that is x to the power of 3. So when you simplify further, this gives you 1, while this gives you x, and this gives you x squared over 2 factorial, while this gives you x3 over 3 factorial, and so on. Now, if you understand the concept of Taylor series, it is a plus while solving Laurent expansion related problems. So now, how do you tackle a problem like this? The first thing you need to know or work on is your singularity, the indicated singularity, which is z equals minus 1. So this simply means that z equals z minus 1 is equal to a number u or a variable u. So with this, write this given problem in forms or in terms of u, which means e raised to power 2. Since z equals u plus 1, then this can be written as u plus 1 over, since z minus 1 is the same thing as u, we can write this as u to the power of 3, which can be further simplified or expressed to be e raised to power 2u plus 2 over u raised to power 3, which is still the same thing as e raised to power 2 multiplied by e raised to power 2u. Indices. So when you have something like this, looking at this new expression, we can see, or we see, that e raised to power 2u can be expressed using Taylor series, or can be written in form of Taylor series. So we need to split that aside and write it in form of Taylor series. So let's do the Taylor series of e raised to power 2u together. When f of u is equal to e raised to power 2u, we are using the Taylor's expansion, that is fn of 0 over n factorial times u to the power of n. So now let's differentiate u. When you differentiate this, you have 2e to the power of u. When you differentiate again, you have 4e to the power of 2u. When you differentiate the third time, you have 8e to the power of 2u. Now you can continue, but I will advise that we stop here. Now, what is the value of f prime of 0? What is the value of f of 0? What is the value of f prime prime of 0? And what is the value of f prime 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 of 0? So when you slot in 0 in each of these, you get, this gives you 1, this gives you 2, this gives you 4, and this gives you 8. So now e raised to power 2u can be expressed as, using this now, that is 1. We are dealing with the first one now. 1 over 0 factorial, that is when n is 0, times u to the power of 0, plus, now f prime of 0 is 2. So 2 over 1 factorial u to the power of 1, plus 4 u to the power of 2 over what? 2 factorial. Interesting. And the third one, 8 u to the power of 3 over 3 factorial. And this can continue. So now if you break this down, you have 1. The whole of this gives you 1. Why this is the same thing as 2u, and the next one, 4 can be written in form of 2 to the power of 2, which is the same thing as this. 2 factorial plus 2 can be written in form of 2 raised to power 3, which is the same thing as this. You can continue further. So this is the expansion or expression of e raised to power 2u in the form of Taylor series. So now let's take this into the question. So now e raised to power 2 multiplied by e raised to power 2u over u raised to power 3 is the same thing as e raised to power 2 over e raised to power 3 into, now we want to bring in e raised to power 2u, which is the same thing as saying 1 plus, which is the same thing as saying 1 plus 2u plus 2u squared over 2 factorial plus 2u 3 over 3 factorial, and so on. So when you simplify further, you can bring in e to the power of 2. When you open the bracket with this, plus you have 2e squared to the power over u squared plus 2e squared over u plus 4e squared over 3 plus, you can continue further. Now that you have this, recall that the value of u is the same thing as z minus 1. So instead of writing u, you return it to the form in which the question is given. And that's e raised to power 2u over z minus 1 to the power of 3 plus 2e over z minus 1 to the power of 2 plus 2e squared over z minus 1 to the power of 1 plus 4e squared over 3, and it continues like that. Now, you need to understand these three things about singularities. When you talk about singularities, you need to understand these three things. One, Laurent series has two parts. The first part, or one of the parts, is the analytic part, and the other part is the principal part. The analytical part is usually in the form while the principal part is usually in this form. Now, the difference between these two is that this one is starting from 0, this one starts from 1. That is the value of it. There must be a power, because if there is no power, then you do not have means z is not in the denominator. So now, if you have something like this, we refer to this as the principal part. So now, from this given question, we see that from this part, we have the principal part, and from here downward we have the analytic part. So now, what do we need to understand? The first thing you need to understand is that if the principal part does not exist, that is, after your expansion, you do not have principal part. You see, if principal part is 0, you call it a removable singularity. Number 2, if the principal part exists, that is, if the principal part is there and it is finite, that is, you can count the number of terms of the principal part, then you call it a pole of order n. That is, n is the highest power of the denominator. So you call it a pole of order n. Now, the third thing you need to know is that if the principal part exists and it is infinite, if the principal part exists and it is infinite, then you call it an essential singularity. So now we can conclude that since this is the principal part, and is it finite or infinite? It is finite because it is countable. 1, 2, 3, just 3 of them. So what you need to write now is that it is a pole. A pole of order 3. The order of the pole is 3. So it is a pole of order 3. And What do you say about the region of convergence? It converges at every region where z is not equal to 1. But at the region where z is equal to 1, it diverges. So if you find this video helpful, subscribe to this channel for more detailed explanation on every concept that student finds difficult. Thank you. See you in my next video.